Very good afternoon to you all. I welcome you for today's session on Introduction to Cloud-Based Geospatial Data Processing. In this lecture, we will be covering the basics of cloud computing, what is computing, different types of cloud computing, and different cloud computing services available. Then I will briefly touch upon basics of remote sensing because we are talking about image processing. So we will just cover what are the basics of remote sensing. Then I will be covering two cloud computing platforms, two open source cloud computing platforms, which you can use, like once you get familiar with, you can use it freely for your image processing tasks. Then I will be introducing two open cloud computing platforms. One is called Google Earth Engine. So I will be introducing to the basics of Google Earth Engine. Then what is different data catalog available at Google Earth Engine, like what all data are available at Google Earth Engine. Then for different Earth Engine data models, how data is actually represented on the Earth Engine so that you can easily process it. Then the how the actually data is represented. So if you know the basics of data model, then it becomes quite easier to handle the data. So you can write code more easily if you are comfortable about the basics of data models. Then we will introduce you to another open source cloud platform that is called Microsoft Planetary Computer. So both are similar to one another, but Google Earth Engine is a bit matured, but Microsoft Planetary Computer is relatively new, but it is also picking up very fast. So either of this you can use for your tasks. So now we will start with what is cloud computing. So basically, if you look at the definition of cloud computing, so the definition says cloud computing is the on-demand delivery of IT resources over the internet, or that's called the cloud, with pay-as-you-go pricing. So means it's the delivery of all IT resources. IT resources may be like computing infrastructure, and includes servers, or it may be storage. So suppose you have huge amount of data to be stored, so you get storage space, or networking devices, databases. So whatever you need, all the IT computing resources that are that you can access on the demand. So whenever you need, you just access. After it is completed, then you can just release those resources. And with pay as you go pricing, so you need to just pay for whatever you use. So you need not, like in the traditional computing infrastructure, what we used to see, like here you can see that suppose we used to house all the servers, storage systems, everything on our premises. So then, so for that we need a huge investment, and then once invested, then for maintenance also we need to pay a lot a pay price. So instead of, like, you are taking electricity connection, so for getting electricity at your house, you are not building a powerhouse at your house, right? So you are just taking the services from a distribution company. So that may be in turn maybe taking from some production company. So like this, and you are paying for the electricity whatever you are using. So you are not building infrastructure at your house itself. So similar concept, if you take in the computing environment, here also the similar thing, like you you all the internet, all IT resources are delivered to you as a service. So you need to pay just for your usage only. So instead of buying and owning and maintaining, instead of owning, buying and maintaining physical IT infrastructure, you can just access technology services such as computing, power, storage, and databases on as need basis from any cloud provider, same as electricity or water supply at your house. So anyway, it offers you faster innovation and the flexible resources and economies of scale. So now here you can see that, like, now everything is, so here you are sitting on your home just with a computer with a basic browser and internet connection, and all the resources are hosted by a cloud service provider. So you are just accessing those resources just as a service and paying for whatever services you are using. Now, if you talk about, like, why cloud computing, like what are the benefits of cloud computing? So the foremost advantage is cost savings. So you are not buying the entire IT infrastructure. So suppose if you are if you have to set up a big data center at your premises, so you need to invest a lot on like first you need to set the buy the physical space, then power supplies, then those servers, storage, and everything, and it takes a turnaround time also is going to be huge. So if you just go for the cloud services, you are going to save a lot on cost. Then second thing comes speed. Speed means now now suppose now with the speed what you can do, you can scale your resources. Like suppose if you today you need just only 10 computers, so you can just buy for 10. Now suddenly what has happened, suppose you have deployed some software and suppose the demand has increased. Now instead of catering to 100 consumers, you need to cater to 1000 or 10,000. So but suppose if you are hosting the infrastructure at your premises, then scaling up that infrastructure takes a use of time and resources in terms of money. And plus now suppose that 1000, it might so happen that those 1000 users are just you are coming just for a month or 2 months, but for catering to their requirements you need to buy the entire infrastructure, and 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 that cost will be too huge. But in case of if you are going for the cloud, so just suppose if you need 1000 servers just for a month, so you can just pay for that 1 month only, then remaining time you can pay your base prices only. So with this speed, and it offers you scalability on your demand. Like so today you need 1000 computers, you can buy for 1000, and tomorrow suppose you need only 10, then you need to just pay for 10 only. So it gives a big advantage there. Then deploying globally in minutes. So suppose if you want to offer your services globally, so within just few clicks you can deploy your services worldwide. Then increased productivity. So definitely your productivity is going to increase, because now you are paying, you are just paying attention, you are just concentrating or applying your resources just on the task or development task with what you are supposed to do. So maintenance and other things are being taken care by the cloud service provider. So you need not worry at all about those setting up the infrastructure, scaling, maintaining, and so on. So you need to just focus on your task only. So with that, you see that the productivity gets increased. Then performance. Anyway, definitely as you can scale up or scale down your infrastructure as your demand increases or decreases, definitely your performance will increase. Then reliability. So suppose if you are going to set up the infrastructure at your premises, then you need to take care of reliability as well. Or suppose if you are a small organization, so there it may not be feasible to host like multiple may not be feasible to host redundancy. So but with the case in case of cloud infrastructure, because the cloud service provider itself will have the redundancy in place, so you need not worry about the reliability of your system. Then security as anyway, because all the cloud service provider are offering best security, or following the best security practices in the industry, so you need not worry about the security of your data. So these are the prime benefits of cloud computing. Now if you see about types of cloud computing, basically there are basically if you broadly, the cloud computings are divided in three types. One is called public cloud. So public clouds are owned and operated by a third party. So any user who is interested in taking the services or interested in cloud computing, they can just go and subscribe to any of the cloud service provider like Amazon AWS, Microsoft Azure, or Google Cloud. So these are publicly available and operated by these service providers, and anyone interested can go and avail those services. The second type is called private cloud. So a private cloud refers to the cloud computing resources used exclusively by a single business or an organization. So so suppose some company or organization doesn't want its data to be put on the public cloud because of some security or other concerns. So what they can build their own cloud infrastructure that can be shared across their entire organization. So that is called a private cloud. So private cloud will be owned and maintained by that single private entity. So nobody else can access that except that organization. So another third type is called hybrid cloud. So hybrid cloud combines public by technology. So here that allows data and applications to be shared between the public and private portions of the cloud. So hybrid is a mix of public and private cloud. So some data that needs to be accessible for all, that can be kept on the public, and some data that is confidential or more confidential, you can say, can be kept on the private cloud, but there will be a mechanism to share the data between these two clouds that is called a hybrid cloud computing environment. So now if you talk about types of cloud computing services, so basically if you broadly if you see cloud computing services are divided into three categories. One is called infrastructure as a service, or IaaS. The second type is called platform as service, and third is called software as service. So if you look into more detail, so infrastructure as service, this is the most basic category of cloud computing services. So entire IT infrastructure can be availed from the cloud service provider. Now suppose if you are only interested in buying only the entire IT infrastructure and all the management and everything, suppose you want to do at your own, so then that is called, then you are taking the services at IaaS or infrastructure as service. So you can buy, like here you can say you are going to set up a data center, so you can buy servers, storage or networking devices, firewall, security. So then these can be accessed from your browser. So when you are buying just servers and all IT infrastructure, you are buying from a service provider, but you are going to manage it yourself. So then it is called, you are taking the cloud services as infrastructure as service, or IaaS. So entire IT infrastructure you can buy. So what are the advantages of using IaaS? So it reduces capital expenditure and optimizes costs. So you need not invest much on the IT infrastructure. So you are just buying the infrastructure, so that will cost you less. So definitely it is going to save you on the cost. So increases scale and performance of IT workloads. So anyway, as we talked in the previous slide as well, so when you are going for the cloud, scalability becomes quite easy. So you can easily scale your IT workload. Suppose now your services are, you need 100 more servers or 1000 more servers immediately just for a month. So then just you can scale up your resources, and suppose if you don't need those 1000 servers after a month, then you can just scale down your resources. Increases stability, reliability and supportability, definitely, and improves business continuity and disaster recovery, as your data is, all your servers and everything is hosted by the service provider, plus it will have definitely a backing up infrastructure as well. So the business continuity and disaster recovery will have better options. So the second thing is called second type of computing service is called platform as service. So PaaS refers to the cloud computing services that supply an on-demand environment for developing, testing, delivering and managing software. So what PaaS contains your IaaS plus development tools, maybe development tools, database management, business analytics tools, plus operating system as well. So in case of IaaS, you were just subscribing to the IT infrastructure, but in case of PaaS, you are subscribing to the IT infrastructure plus as well as tools, like all development tools for developing, delivering and managing software applications. So here you need not worry about the infrastructure. You are buying the entire platform, not just IT infrastructure. So, so here you need to just focus on your development work only. The infrastructure management will be taken care by the cloud service provider. So this is basically designed to make it easier for developer to create applications without worrying about the setting up or managing the infrastructure. So underlying infrastructure will be managed by all tools, whatever you need, tools, operating systems, whatever, or development environment, whatever you need will be provided you by the a service provider. So you need not worry about that. You need to just focus on your application development, and other infrastructure will be taken care by the cloud service provider. So what is advantages? It cuts your coding time because you need not worry about setting up or managing the IT infrastructure or platform required for developing your application. So definitely it is cuts your coding time. Then add development capabilities without adding resources. So anyway, when you are buying or subscribing to the entire platform or tools, so you will be getting new and new tools. So so with this you are adding capabilities to your existing resources, and we are without any additional resources. So then, because cloud and IT infrastructure, so you can develop it your application for multiple platforms quite easily. So whether you are developing for mobile or some desktop applications, so easily you can develop for multiple applications. Then supports geographically distributed teams because entire platform is available on the cloud, so anybody any of your team member can access that from anywhere in the world. Those the third type of cloud computing service is called software as service. So SaaS refers to cloud computing services that delivers on demand software application over the internet. So you here even you need not worry about the tools also. So entire software will be delivered as an application to you over the internet. So cloud providers host and manage the software applications and underlying infrastructure and handle any maintenance. So you might have taken the example of any suppose some company doesn't want to host email services. So what they can do, like they can take the email services from Google or Microsoft like Outlook. So then the users can directly access. So entire infrastructure for maintaining the mail servers is handled by the cloud service provider. So here entire software and underlying. So it contains IaaS plus PaaS. So this entire infrastructure is managed by the cloud service provider. So user just can connect to the application over the internet, usually with a web browser or a phone. So all underlying infrastructure is maintained by the cloud service provider. So you are just accessing the software for service, software as service, like you are using any webmail services. So those are this example of software as service or SaaS. So even today whatever we will discuss about image processing, that also we can categorize as a software as service, because we are not worrying about anything like where the data is stored, how the data is stored. We are just through our browser we are accessing those services, or you can say that we are accessing image processing as well as the GIS software using just our browser. So that computing services is called will be categorized as a software as a service. So what are the advantages of SaaS? So gains access to sophisticated applications. So what might happen, like suppose if you want to host email services at your infrastructure or at your campus, so you may need very sophisticated infrastructure to handle those. You may need servers of special type and databases or special types or with certain requirements. So now suppose if such requirement is there for hosting your application, so you need not to buy that sophisticated hardware. So with this, quite easily all sophisticated application you can gain access to those sophisticated application with SaaS. So all sophistication will be handled by the cloud service provider. So generally free client softwares we get with those themes. Access app data from anywhere, as data is stored in the cloud, so it can be accessed from anywhere. So these are the advantages of using SaaS. So this was all about cloud computing. Now to talk about remote sensing. So what is remote sensing? In the previous lectures you might have studied about. Just for the sake of completion I will be covering it. Art and science of obtaining information about an object or phenomena through analysis of data that is obtained by a device that is not in contact with the object or phenomena. So means deriving or extracting information about an object without being in contact of that object is called remote sensing. Like, so when you take a photograph, or suppose if we are seeing it with our eyes, so an image of an object which are looking at is made is formed in our eye. So we are without coming into the contact of that physical contact with that device, we are just extracting the information about that object is called remote sensing. So here we can see that an image is represented as a grid or cells of pixels. So as you see how an image is taken, so everywhere and everything reflects and absorbs it differently and measurably. So the reflected energy from an object is captured by a device and that is displayed. So this is our entire electromagnetic spectrum. So in this entire electromagnetic spectrum, this is small portion of the EM spectrum is called visible, that we can see. But with the help of remote sensing, if we have cameras which can capture energy in ultraviolet or infrared range or even microwave microwave range also, then we get more information about the object. So similar way, so what are the images? So images are stored as a raster and can have one or more bands. So when the energies, the sensor may collect EM electromagnetic energy in different bands, blue, green, or red band. So then panchromatic or monochromatic bands images. So there are two types of images: panchromatic, or what you can say single band image, or multi band images. Panchromatic and monochromatic images, they have just single band. Color images might come have three bands, maybe RGB or some infrared or ultraviolet also. So when we combine three bands together, we get a color image or composite image. So multispectral images have four or more bands, each of which is spectrally narrower and extends beyond what human eye can see. An image can have 4 or 5 bands. So when displaying an image, but actually suppose our image might have 6 or 7 bands, but while displaying that image, the display monitor actually has only 3 bands. So out of those 6 or 7 bands, only 3 bands we can choose for display. So this may be like, suppose if we have a band different images in different bands, so then when we combine all 3 bands together, then we get a composite RGB image. So like this is the how the color is formed. RGB, when combining, we get a colored image. So as I explained here, now suppose this is an example of, now suppose our instrument or sensor might have facility to capture EM energy in maybe 5 or 6 bands. So out of these 6 bands, we can select or represent any 3 bands, because our display we can combine only 3 bands together. So out of these 6 bands, we can select any 3 bands to be represented as blue, green, or red. So out of these 6 bands, like band 1, maybe go to the blue, or we can select band 4 to go to blue, or band 2 to green, and band 6 to red. So this way we can combine, we can make different combinations. So and then we can make a composite image. So that those are called false color composites. Now this is about remote sensing. Now because our today's topic is image processing on open cloud platforms, so I will be discussing about 2 open cloud computing platforms that are available, so that we will categorize as software as service. One is Google Earth Engine. So Google Earth Engine is a planetary scale platform for earth science and data analysis, and it is powered by Google Cloud's infrastructure. And second, what we will talk about, it is a planetary computer, Microsoft planetary computer, a planetary computer for what they call planetary computer for a sustainable future. So now, what is Google Earth Engine? So Google Earth Engine is a geospatial processing service powered by Google Cloud platform. So what is a geospatial processing service? So here you can categorize is at software as service, because here you can say that we are accessing, we don't care about how the data is stored, where the data is stored, what platform is used, and so on. So it's just, we will be using just a web browser. So you can say that with the web browser, we are accessing a gamut of storage infrastructure that hosts all the satellites data. Plus, we are having access to a image processing software and a GIS software combined. So we can say Google Earth Engine is a geospatial processing service that is hosted on the Google Cloud platform. So it is a planetary scale platform for Earth science data and analysis. So planetary scale means there is huge amount of data available on the Google Earth Engine. Almost petabytes of data from the all open source data is available on the Google Earth Engine, and you can analyze and all of those data just with a few clicks, or we can say with help of few commands. So it's a planetary scale platform. Then it combines a multi-petabyte catalog of satellite imagery and geospatial data sets with planetary scale analysis capabilities. So it doesn't just store the data. It gives you the tools, access, process, and visualize that data to get more insight of the data. So it provides an interactive platform for geospatial algorithm development at scale. So now suppose if you are if you are already have been working in remote sensing application development, what generally a user will be working on a small area. So even we get, suppose if you are I am working on area of Uttarakhand. So for getting the Landsat images of Uttarakhand itself, it takes it needs to take it takes a lot of time even to download that data. Once downloaded, suppose if I downloaded that 20 years data, now I cannot process that data in a single workstation. I need very high end servers for processing that data. So but suppose if I don't have access to any of these resources, then Google Earth Engine is the best option for me. It provides me an interactive platform for geospatial algorithm development at scale. So I can develop application at global scale quite easily. That which is not possible on my workstation or server. So if we see the data catalog of Google Earth Engine, so it has all open source. It hosts data available from almost all space agencies which are providing their data as open source, from NASA, ESA. So all the satellites, whatever you see, almost it has all type of geospatial data available at Google Earth Engine with just with few clicks. So, a planetary scale platform for Earth science data analysis. Earth Engine's public data archive includes more than 40 years of historical imagery. So that, in general sense, that is not possible. So, if you are interested in historical data as well, so almost more than 40 years of historical satellite imagery, as well as various scientific data sets are available at Google Earth Engine, and not just data. So it gives you the capability to analyze that data also with few clicks. Plus that data is updated and expanded on daily basis. So whatever data is new data is acquired by the new satellites, maybe Sentinel, Landsat. So that data also will be available to you immediately after the acquisition. Plus, because now just having the data, now suppose data, even if data is available, and if I give you the 40 years of Landsat images for your area, but what you cannot process that data with simple infrastructure. So for accessing or processing that data, the entire Google Earth Engine platform is backed up by the Google's big cloud infrastructure. So you see the all distributed systems, parallel processing, everything is available. So you need to just know a few basics. So if you talk about the benefits of Google Earth Engine, it's a big data analysis and visualization platform. It is inherently parallel system, because when you have to process the data at that scale, so you need definitely parallel system. So inherently, whatever commands or commands you are writing, or data access commands you are writing on the Google Earth Engine, so those all commands are inherently executed in parallel on different machines. You will not come to know about that, but on the back end, all the processing will be done in parallel. So, and you get results within a seconds. So basically, Google Earth Engine is designed for scientists, not for software engineers. So for using Google Earth Engine, you need not to be expert software engineer. So if you just know few very basics of programming, then quite easily you can adopt to it. So basically, the motto of Earth Engine was to design it for scientists in remote sensing community who are not well versed with the software engineering practices can also easily analyze or visualize their data. So its goal was to make it easy or enable non-traditional users to come into the remote sensing domain and analyze their data easily. So it is focused on society, solving the society. So if you are working in this area, it is basically focused on solving the society big challenges like deforestation. This is what our society is facing, the issues today like deforestation, drought, disaster, disease, climate change, conflict, food security, sustainability. So if you are interested in solving any of these problems, you can switch over to Google Earth Engine and you can find answers to your questions quite easily. You need not work so hard. So this is, you can see that at a scale you can see the data on Google Earth Engine. So like suppose this way, if you have to make this mosaic of Landsat images of this much area, so it takes a lot of time and resources if you are going to do on your local system. But with the help of Google Earth Engine, just with a few clicks, you can create a cloudless or cloud-free mosaic within a few clicks. So like this, then scalable at scale. So generally, your when you want to scale up your study to the global level or at global scale, so that is not possible with a single machine. So with Google Earth Engine gives you the capability to scale your analysis to the global scale quite easily. Then you can, because almost 40 years of historical imagery is available, so you can create time lapses like how the area of your interest has evolved, or like if you want to study that how the things are changing in the world on the daily basis. Like here you can say how the snow cover is changing over the years. So this way you can study at the global scale quite easily. Here you can see that how a river is changing its course and the urbanization is taking place. Urbanization and deforestation is taking place. So this way you can make, because 40 years of data is available, you can study the changes happening in your area of interest. Like here you can say how the city is expanding and the forest area forest or agriculture area is getting converted to the urban areas. So this way you can create time lapses of your area of interest. Here you can see how deforestation is taking place or urbanization is increasing. So these all are available on these animations. I have taken from the Google Earth Engine's website. So these are available there and for certain areas, and even you can create these time lapses for area of your interest. So I will be just in today's second part of this lecture, I will be demonstrating some basics like how do you access this Google Earth Engine, and then once you familiar and explore more about it, then you can create these animations by yourself as well. Then if you talk about Earth Engine data catalog, so Earth Engine has a very huge data catalog available. So if you talk about Earth Engine data catalog, it has more than 200 public data sets available. Then you can say that these are approximately more than 5 million satellite images are available at Google Earth Engine, and so with you can analyze those images just with few clicks. Plus more than 4,000 new images are added every day. So if you talk about today's, almost more than 60 petabytes of data is available at your disposal. Just with a few clicks, you can get answer to any of the questions which you want to know. But okay, so there's the data available on the Earth Engine catalog is Landsat, all Landsat series, entire data is available right from Landsat 1 to Landsat line, which is launched recently. So with this special resolution 10 meter to 30 meter, and the data, because the temporal resolution of Landsat is almost 16 days, so that also you get. And Sentinel-1, all synthetic aperture radar data or Sentinel-2 that is having optical data. So all the Sentinel data and Landsat data is available. Then Modis data is available. Modis data is available at daily. So if you are interested in seeing the daily changes, then you can access. If you are interested in working in Modis data daily, and Modis data also is available. Then some vector data, different countries, boundaries, and some data in vector tabular format also is available. Then some thematic data like terrains, digital elevation models, land cover, then how land covers are changing. Suppose if you are interested, land cover changes, weather and climate data from NOAA, NCEP and all, so weather, climate data. So whatever, you can just name the data what you are interested in, and you will find it on the Google Earth Engine. And suppose there is some data which is missing there, then you can request them to add that data also, then they oblige to that. So the data available anyways is big data. 40 plus years of Landsat imagery is available for you just with few clicks. So anything you want to study globally, you can just with the few clicks you can. Then daily Modis composites. So actually Modis is scanning the entire Earth on the daily basis. So suppose if you are interested in monitoring daily changes, so with the help of Modis data, you can use Modis data also. All the products available from the Modis, whether Earth, ocean, all the data products are available on Google Earth Engine. Then suppose if you are interested in atmospheric or climatic studies, so a lot of atmospheric and climatic data also is available on the Earth Engine. And Sentinel-1, suppose if you are interested in synthetic aperture radar data, so Sentinel-1's entire data is available on the Google Earth Engine. So if you like computation platform, how does it work? So it works in two modes, on the fly and batch computation. So on the fly means suppose now you want to interactively write and you want to interactively write a command and visualize or analyze that data interactively. Like suppose I will write a command and immediately I want to visualize. So both the ways it is possible. You can interactively or batch computation. So when you are doing large scale parallel computation, or suppose if you are interested, you want to do a batch computation like for multiple areas in different times. So you can submit your job as a batch or as an interactive platform. So just you run a command, visualize the result, go to the next with batch. So both ways it is possible. So basically the Google Earth Engine is working on a client server model. So you write a request on the client side. So all the geospatial data sets and operations on that or algorithmic primitives, storage and computation, everything will be done at the Google's cloud infrastructure. So on your browser, you just write a processing request in JSON form that will be submitted to the Google Cloud server, and the results will be returned to you back in a form of image or JSON. So this is a client server architecture. So data models, how the data is actually represented in Google Earth Engine. So all features or vector data is represented as a feature containing line, point or polygon with a list of properties. So all vector data is represented as a feature. Then an image, or a raster image is represented as a stack of geo-referenced bands, and every band will have its own mask, projection, resolution, or a list of properties, maybe like when the data was acquired, bounding box of that image, and so on. So vector data is represented as a feature, and an image is represented, raster data is represented as an image or stack of geo-referenced images. Then what is called a collection. Collection is a bag of elements, or like you can say that a collection where multiple features or multiple images are combined together. So like all images of Landsat 8 acquired till today are combined in a collection called Landsat image collection, similar to Sentinel image collection, or when there are multiple features combined together are called feature collection. So map, there is a function called map. Suppose if you want to apply some processing on each image on that collection, so there are functions like map. So map will apply a function to the entire image or feature collection. Then you can apply reduce or aggregate collection. Like suppose you have Landsat images of all 40 years. Now you want to combine them to a single image by creating a median or average of all those images, all pixel intensities. So that is called a reducing operation. Or you may be interested in extracting statistics about certain, not on the entire image, certain specific area of interest only, some vector data. So that also can be done using reduced operations. So then the second platform what I will talk about is Microsoft Planetary Computer. So Microsoft Planetary Computer is another platform available for geospatial data processing on the cloud. So the Planetary Computer combines a multi. This is also similar to Google Earth Engine. So Planetary Computer combines a multi-petabyte catalog of global environmental data with intuitive APIs. So actually, Google Earth Engine also offers you APIs in Java or sorry JavaScript or Python. So similar way, Planetary Computer also, it has a multi-petabyte catalog of global environmental data with intuitive APIs. So the data is available and you can access it using APIs. It is a flexible scientific environment that allows users to answer global questions about your data. So all historical data is available, and plus so this Planetary Computer offering you a scientific environment. So with that you can just extract useful information from that stack of data, because it gives you the tools to extract information from that data to know the answers of global questions about your data. Then the Planetary Computer Hub is plus it is a development environment also that makes data and APIs accessible through familiar open source tools that allow users to easily scale their analysis. So both are working in the similar way, either Microsoft Planetary Computer or Google Earth Engine. Planetary Computer is a bit newer, but it is also picking up quite fast. So what are the various components of a planetary computer? If you see, planetary computer has a data catalog. Data catalog, it's detail about what all data is available on the Microsoft Planetary Computer. So it's a planetary computer, includes petabytes of environmental monitoring data and inconsistent analysis ready format. So the data, you need not do any pre-processing on the data. So the data is already inconsistent and analysis ready format, accessible through your APIs. The second part is APIs. So for accessing that data catalog, they have given open source APIs. So that open source APIs make it easy for the user to find exactly what data they need. Because there are a lot of data available, but you may be interested in some particular data only. So with the help of APIs, you can search in or search your you can search the data which you need only from that entire stack with the help APIs. Then Planetary Computer offers you a hub. So Planetary Computer Hub is a development environment that makes your data and APIs accessible through open source tools and allows users to really scale their analysis. So or suppose if you want to access the computing infrastructure, so that you can access through hub. Plus there are multiple applications developed by different partners of Microsoft. So those applications are those applications in the form of web applications are available to users. So from applications you can see the results of different analysis you are interested in, like forest monitoring and all. So different applications developed on this Microsoft Planetary platform are also available for public. You can access those applications also and know more about what things are happening. So if you talk about Microsoft Planetary Computers data catalog, it also hosts petabytes of data, a lot of satellite imagery and other ground collected data is available on the Microsoft Planetary platform as well, Microsoft Planetary Computer. So all the data which is available on the Planetary Computer is inconsistent and analysis ready format, what they call ARD. So all these data sets can be accessed. So actually they are stored in Azure Blob storage, so they can be accessed using APIs. So all the data is available, like maybe Sentinel images, Landsat, star images. So some ground monitoring data also is available, or thematic maps, biomass, vegetation, and so on. So Microsoft Planetary Computer Hub is also similar to Google Cloud Platform. So this is also based on Jupyter Hub environment. So this is also client server terminal based on client server architecture. So the planetary computer uses open source tools and supports open standards. So everything is based on the open source tools. So it has incredible ecosystem of tools that are being developed by the community, by a by a broader open source community. There is an incredible ecosystem of tools. So like suppose if you need, already the tools may be available for your analysis. So you need not write even some tools. So many things may be available. If you have very specialized requirement, then even then you yourself can develop the tools and publish it for the others to work. So Microsoft Planetary Hub is built on the work done by the Pangeo community to put the tools of data science to work for Earth science community. So Pangeo community is working basically on the data science tools. So their tools has been reused for work by the Earth science community. So APIs are built on the works of Stack community. So all the APIs are based on the Stack spatiotemporal accessing catalog. They are Stack is for streamlining and standardizing the cataloging and discovery of this geospatial data. So all Stack, so all the APIs are based on the Stack Google Earth, Microsoft Planetary Computer. So the slides here are taken from Earth Engine, Microsoft Planetary Computer, and Google Earth Engine AI introduction. So this was the theoretical part. Now I will demonstrate you how do we access the data available or whatever data I talked about on the Microsoft. One more first I will demonstrate about Google Earth Engine, then we will go to the details of Microsoft Planetary Computer. So as I explained in my previous lecture, but one thing is required for accessing Google Earth Engine or Microsoft Planetary Computer. First you need to get access, or you need to apply for the Google Earth Engine. So which with your Google account you can just apply, or you can search on like sign up. So if you are new to Earth Engine, then you can just sign up. So anyway, you can reapply. Because my case it was applied, so it is asking for reapply. So they will ask for some basic few details about what you will be using and so on. So once you sign up, once you send the request, they will approve your request, and immediately you get the access to the Google Earth Engine. Once it is done, the Google Earth Engine. So go to Google Earth Engine. So if you search on the Google Earth Engine platform, you can talk about. So Google Earth Engine offers two APIs in two languages. One is in Python and another is in JavaScript. So JavaScript has, if you are going to use JavaScript, so JavaScript has an inbuilt code editor also. So directly there you can write code in JavaScript and visualize. Plus, suppose if you are interested in writing in Python, so for Python also APIs are available. Both APIs are quite similar. If you are comfortable with one of the APIs, you can switch over to another APIs, or you can install those APIs on your local system also, and then you can access. Once you access your account, so first thing I will explore you like to tell you about the data set. Now, whichever data sets are available, you can search on the, you can go to the data sets tab, and you can see like suppose you can search from your data set of your interested: surface temperature, climate, atmospheric data, weather data, imagery. So if you are interested in imagery, you can search for Landsat, Sentinel, MODIS. This way, almost all data, whatever you just name the data, it will be available here. So from the catalog, you can search about your requirement. Once this is done, actually Google Earth Engine. So suppose if you don't want to write code, so for that there is something called Earth Engine Explorer. So just with Earth Engine Explorer, you can, without writing the code also, you can view the data. So just you can go to this, and first you need to sign in. So I will be signing into my account. So from here, you can like add data. Suppose I'm interested in adding some land cover data. From here, you can search for Landsat or something also, right? Now I'm interested in land cover data. So I can say like Copernicus, I want to see the Copernicus global land cover layer. So here I can add the layer. Similarly, I can add any another sentinel image or any other image also. So here like this, you can add and you can see the result. So then you can do some, you can add some computation to the this. You can add new bands to image. You can do like suppose if you want to classify, do the classification or some machine learning algorithms you can run. You can do some more convolution, any operation if you want to run on this, that also can be done quite easily. And you can add new datas like modis, IGP, whatever you want. This way you can add and visualize data together, and some basic analysis also you can do with just Google Explorer without Earth Engine Explorer, without writing any specific code. Now I will show you how to write access this data using APIs. So for that APIs, now once, as I explained in my previous lecture, you can use Google Colab for this. So anyway, because so first thing you need to so you can go to Google Colab anyway the direct, because I have already created a notebook for demonstration. So you can just so once Google Earth Engine has approved your account, then we will be accessing the Google Earth Engine cloud services using Python API. So let us see how do we do. So for that, as I explained in my previous lecture also, first thing actually we need a package called EE. So suppose if you are using on your local system, then you need to install this EE package. Otherwise, if you are using on Google Earth Engine, Google Colab, directly EE is already installed, you need not to do anything. Then for visualizing the data, so as I explained that it works on a client server architecture. So as a client, we will be requesting what all data we need, and then we will send a request in JSON format, and then the Google Earth Engine will search the data on its infrastructure and return back as the results. Then those results we can visualize. So for visualizing it on the map, as I explained in my previous lecture, there is a library in Python called Folium. So I will just demonstrating you the basic of Folium. Actually, you need not know more about the Folium anyway. This is just not the main topic of our problem. So I am just importing first two packages. One is called EE and another is Folium. EE is for accessing Earth Engine, and Folium is for visualizing the data on the map. So if I run EE and Folium, so first thing I need to run is ee.authenticate. So with ee.authenticate, we are authenticating our username, and we are authenticating ourselves like for accessing, or we are authenticating, we are giving permission to our Google Earth Engine to access account. So e.authenticate, if you call, then it gives you a click for authenticating yourself. It gives you a link. So on the link, if we click and key in our password, then it generates a token. You select your account. Then here you need to give it access to read and write. Then continue. Then here it generates a token for authorization. So once copy this, I will with Control V, I can paste it here. It said successfully saved the authorization token. It means we have authorized ourselves to the Google Earth Engine. Next, once authentication is done, you need to call a function called ee.initialize. So with this, Earth Engine gets initialized. Now actually this is a function for masking the clouds on image. Right now you need not worry about this. You can just copy and paste it. Then next thing comes, as I explained you, the image, all the images in Google Earth Engine are like all Sentinel images or all Landsat images are combined in a image collection. So image collection represents images, all images of a particular type, maybe like all Landsat images are combined in a Landsat collection. Sentinel images are combined in a Sentinel connection. So here we will see that latest, suppose if I want to visualize latest Sentinel-2 images acquired over the world. So actually the collection will contain all the images, like from the starting date when the Sentinel-2 acquired its first image till the today. So all the images and all the areas of the Earth. But we may be interested in some particular time or some particular area only. So sorry. Google Earth Engine gives us facility to filter those images either temporally or spatially, or suppose if you can filter it using cloud cover and so on as well. So first thing is, first you need to know the name of your image collection. Like suppose if you are interested in Sentinel-2 images, now the question comes, how do we know the name of your image collection? So that will be available here. Google Earth Engine, if you go, if I go to data sets, and suppose you are going to imagery, then suppose if I go to Landsat, so Landsat, with every image collection, there will be a name attached to that image. So suppose if I am interested in surface reflectance product, so here you can see this is here, right here. This is the name of image collection. So first from the data catalog, you need to know the name of your image collection, that you need to key e.image collection. So here you can see that I have created a data set equal to e.image collection. So image collection, I have given the name of image collection. So Sentinel-2 image collection is named S2 underscore surface reflectance. Product is S2 underscore SR harmonized. Then with this I have accessed the entire image collection, but I am not interested in the entire image collection. So I am interested in the images which are acquired between 1st October 2022 to 3rd or 4th November 2022. So once the image collection is done, what I can do, I can filter it by date. So e.image collection dot filter date. So here I can specify my starting date and end date in this format. Later on, I can filter it on some more parameters like spatially. So suppose I am interested, I am sitting in India or near Dehradun, so I can filter spatially as well. I will draw a polygon around my area of interest, and I can filter it around that area as well. Then we have put another filter on this image like e.filtered dot less than, like we want to access only the images which have cloudy pixels less than 20%. So those images, because we just wanted to have a cloud free image collection. So this way, once you get an image collection, you can filter it spatially, temporary, cloud cover wise, or there are multiple filters. You can go through the documentation. Then there is a function like map. So as I explained, map is a function that is applied iteratively to the all images of a collection. So here we just wanted to mask S2 clouds. So there is a function called for masking the cloudy pixels in an image, so that you can just copy and paste from this example given here. So this way, so here we are doing creating accessing an image collection, filtering it by date, filtering it by cloud cover, and masking the cloud pixels in that image. So if you see now, data set is our. So now there I have defined a function in Folium for adding this image collection to a map. So right now you need not worry about this function. You can just think it as a black box, and then you can take it from the documentation right now. Once you are comfortable with some basic Python programming, then you can go through this function and you will quite easily understand this. Very few simple steps are there. So here we can think add E layer as a black box to which we give a Google Earth image, and it just displays that image on a map. So now for visualization, we need to define like visualization parameters, like what is the minimum value, maximum value, and which all bands you want to visualize. Because the Sentinel-2 image has 11 or 12 bands. But as I explained, for displaying that image, we can combine only 3 colors. So out of these 11 bands, we can choose any 3 bands for R, G, and B visualization. So if you take about Sentinel-2 image, so band 4 is red, 3 is already is green. So we are just taking the true color image. So we are for visualization, we are taking 4, 3, and 2 of as R, G, and B. So we have defined a visualization parameter as a dictionary. Then now we are creating a map. So UK underscore map I am calling folium.map. So folium.map is a function for creating a map. So it takes an argument called, then there are the other two arguments it takes, but a mandatory argument called location. Location means when the map starts, so the map will be centered at this location. So UK underscore map, we are creating a map. Then on that map, add EE layer. So here we are EE layer we have created dataset with the name dataset UK underscore map dot add EE layer. So it takes 3 arguments. One is dataset or layer which you want to display on that map. Dataset we have given, this dataset we have given as a layer to be mapped. Then the visualization parameters. Then suppose the name of that layer. So UK underscore map dot add layer. If I run it, so the map is centered at 70-30 and created. Map is overlaid with the Sentinel-2 images. This way you can see that just with few commands. Suppose now if I ask, if you are working in remote sensing already, you know the pain of, like suppose if I ask you to create a mosaic or just download the images of this small area, so actually it takes a lot of time. These images are not properly, because these all images are taken in different times. So the values of intensity are different, but it doesn't look quite seamless. So but with once you learn more, then you can create a seamless mosaic of these images. So this way you can see that just with a few commands you can see the latest Sentinel-2 data, which if you are going to download it from the web, you need not download anything. You do not need any high-end computer, just a browser and a Google Earth account. So now suppose if you want to change the visualization, now this we are showing a true color image. Now suppose if you want to see standard false color composite, there red will be represented as a NIR. Now if I change these colors, band it, NIR I will interpret, NIR I will take as red, and red as green and green as blue. Then you will see the visualization gets changed. So now you can say that just by changing this visualization parameter, I converted the true color image to a false color composite. So I need not download the data. I need not have a very high-end GIS or image processing softwares for doing this. So even though I may not be a programmer, but just by knowing these few basic things, I can analyze the data for almost all 30 or 40 years and get information or answers to the questions, get answers to my questions about that data quite easily. Now this was, we have shown it in data. Now suppose if I want to clip it to certain region only. Now suppose if out of this I am interested only in Uttarakhand, but on true color image. So I can clip this image. So this is just a gist of what we are showing. If you uh, go through the documentation, you will see more details. You can do a lot more image processing, whatever you want at global scale, you can do with just few basic steps. Now, suppose if I want to clip, or I am interested only, suppose I am interested only in Uttarakhand state. So for that, you can upload your shape files to your Google Earth Engine or Google Earth Engine account, and from that you can clip your images, or you can create collection or features here itself. Now because for the here I have just uploaded a shape file of Uttarakhand. In this I am taking it. Now suppose if I want to clip that image and I just want to reduce those all images, because this contains images from October and November all months. So now suppose I want to create a median of all those pixels or overlapping. I just want to create the median composite of all overlapping pixels. So how do we do that? So this is a single command like dataset dot median. If I take call dataset dot median, it will create a single image by taking the median of all overlapping pixels. Then later on I can clip it to my area of interest. Now if I run this, again same thing. I created a map. So you can see that I have just clipped the images of my area of interest only. So instead of doing this, then otherwise you can create a feature or a polygon around your area only, and then you can learn more about Google Earth Engine. So there are very nice videos and documentation available online. So you can go through those things. Like if I go here, docs, or even you can go to the guides. Here, if you go through this APIs, this is brief API and this is in much detail. So you can go through this documentation and either Python or JavaScript, you can go through this and build simple applications. Actually, once you have written a simple code, then you can deploy it as an application also. So once this is done, like we have done, it is working. Let me check. Like this is an application developed by IIRS. On Google Earth Engine. So this way you can create an applications and deploy it, and you can share the links to others so that others can just without writing the code, they can access your application. So they can analyze the data and so on. So this way, once your code is done, then you can build user interfaces and so on, and then even you can share your code as app also, so that the other user can access it. So this is all about Google Earth Engine. Now I will demonstrate you about Microsoft Planetary Computer. So this way, with just few a single few commands, you can access entire satellite imagery which is available on the open source platforms. So if I go to Microsoft Planetary Computer, so Microsoft Planetary Computer doesn't offer as much features as Google Earth Engine, but it also has a big. This is also is expanding. Check out for the latest features. Even this I have not explored. Now the first thing here is like data catalog. If you search this also has quite big data catalog. Now featured data, if you are interested, suppose you maybe Landsat collection, MODIS, Sentinel, air quality, biodiversity, bioma, thematic information, demographies, fire data, satellite imagery from this, land use, land cover. Suppose if you are interested in soil, snow, a lot of almost water. Suppose if you are interested in water, high resolution surface water data. So almost all environmental data, satellite imagery, everything is available. So for first thing, I will explore you about. Suppose if you don't want to write code. So here, Planetary Computer also has an explorer similar to Google Earth Engine. So here also you can visualize. So first thing, you need to select the data set. Now suppose if you are interested in Landsat images, Landsat image collection, you can search. Then it lists you all the data. Then you can search it by date. You can temporarily filter it. Like suppose if you want to with low cloud, and then you can zoom into your area. Then it lists images also. The interface looks a bit different from the Google Earth Engine, but here you need not write like this. You can just go to your area of interest and explore, or then you can create like natural color infrared image, like a false color composite. You can make like this, or you can calculate NDVI for this area also. Directly, you need not write any code. So directly NDVI you can calculate for your scene. Some basics like advanced filterings are available. You can select filters, scene ID, cloud for. So this way, like NDVI, suppose if you wanted to calculate, NDVI you can calculate, just you need not write any code for this. So this way, with the help of you can add multiple layers, change the layers, you can hide the labels, add a new layer, zoom in, and so on. Now the next thing comes here, a hub. So suppose you are a programmer and you want to write code instead of directly accessing it, because your requirement may not be getting fulfilled just by these clicks. So you wanted to write your own code for processing, but for that you need an account. Plus here it has only APIs for Python only. It doesn't offer APIs in JavaScript. So for this you need to be comfortable with Python and some basic stack. So here then there are multiple tutorials available. You can go through these tutorials and you can write the application for meeting your requirement. So this way you can use either Microsoft Planetary Computer or Google Earth Engine for your processing requirements. So this was all about today's lecture. So now if you have any questions, you can post it on the chat box. So after 5 minutes, we will come back and take few questions from that. So thank you very much.